Okay, so far we have just two different decomposition criteria. The first one is to reduce the redundancy. We do this by introducing BC normal form decompositions. We also need to make sure we don't have any information loss, and we introduce lossless decompositions. Besides these two criteria, another very important criteria is to preserve the dependencies we have on the relations. Let's assume if we have a relation, right, and this relation has some FDs. If we can find one FD, x implies y. If after we do the decomposition, we have x in a new relation and this y in another relation. If so, then we can say this decomposition is not dependency preserving. This decomposition can have some problems because if we want to check some dependencies, we have to join these two tables together, right? The target is always to find some FD preserving decompositions. This is also a very important criteria for our decomposition algorithms. According to the previous example, the BC normal form is not always dependency preserving, and in fact, sometimes we cannot even find a BC normal form decomposition which is dependency preserving. Because of this reason, we have to introduce another normal form to handle it. It is called third normal form. Now, what is a third normal form? We can provide a definition of third normal form in this page. So given a relation, we can say a relation R is in third normal form if and only if whenever there is a non-trivial FD, A1 to AN implies B for the relation. Then the head of this FD, A1 to AN, it is a superkey for the relation. The head is a superkey for the relation. It is the same as the BC normal form, right? However, for the third normal form, we have another condition, or B is one part of a key. So the two conditions are either A1 to AN, it is a superkey, or B is a part of a key. If so, then we can say this relation is in the third normal form. I hope you can check this BC normal form definition versus this one. You can find that the third normal form is more relaxed because here we have the or, right? Either this condition holds or this one holds. It's more relaxed than the BC normal form. We can also describe this definition in English. So we can say a relation is in the third normal form if whenever we have a FD, x implies y holds, then the head x is a superkey, or the A is a prime attribute. The prime attribute means it is one part of a candidate key. Head candidate key means it is a key candidate, or it is a key for the relation. Because given a relation, we can have different keys, right? If so, then we can say this relation is in the third normal form. So, in other words, according to the definition for the third normal form, we know that if we have a relation and all the FDs, based on all the FDs, if everything depends on the key or is in a key, if so, then we can say this relation is in the third normal form. Even though the definition seems to be more tricky because it has more conditions, even though it is all, right? However, actually in the real world, the third normal form is very intuitive and it is not very hard to achieve. We can do so based on the BC normal form algorithm we showed before to help us. And when we are doing the project, we normally aim for the third normal form in the designs, unless you have stronger reasons for the BC normal form. The third normal form is more relaxed than the BC normal form, and we want to refine our relation to make sure they are in the third normal form. And we're going to compare the third normal form versus the BC normal form. So if you still remember for the definition of BC normal form, we say a relation is in the BC normal form if whenever we have x implies y holds, then the x is a superkey. We only have one condition. We have no or and more for the BC normal form, right? So you can see the BC normal form is slightly stronger than the third normal form. We have an example in this page. Let's assume we have a relation R with A, B, C as attributes. We have two FDs, A, B implies C, and C implies A. First of all, what is the key for the relation? We know for the relation we have AB as the key, right? Because AB can imply all the attributes, and none of its subset can imply all the attributes. Now, is this a relation in the BCNF number form and the signal number form or not? According to the FDs, right, we have C implies A. C is not a super key, right? Therefore, according to the BCNF number form definition, we can find one counterexample. This FD, C implies A. C is not a super key, then we can say it is not in the BCNF number form. Then how about signal number form? We have AB implies C, that's fine. C implies A. C is not a triple key. However, for the A is one part of a key, right? Because we know for this relation, the key is AB. A is one part in the key attributes, right? A is a prime attribute, is one part of the key. Therefore, we can say this relation is in the third number form, but not in the BC number form. So normally we want to get the certain number form, which is the basic, and sometimes we can also aim for the BC number form if you have strong reasons.